Assalamualaikum guys. Today we are going to study the last chapter of your unit 1 atomic structure, that is the electron gain energy and the electronegativity. Yes, this is Najmunisha Asha. Today I came to explain the last chapter, how the electron gain energy and the electronegativity showing the periodic trains of S and P elements. Right. Let's move on to the final chapter. So the first thing is we have to know the content what we are going to study. From the heading you might understand. Yes, we are going to study the first thing is the electron gain energy. And again the electron gain energy, there is a new term that we are going to introduce, that is what called the electron affinity. And the next one is the electronegativity. Under the electronegativity, we are just going to introduce the Pauli electronegativity values and the periodic trains in the periodic table. Let's move on to the chapter now. The first one. We are going to discuss the electron gain energy. The word is simply resembles what is meant by the electron gain energy. Yes. The energy change that occurs when an electron is added to a gaseous atom is called electron gain energy. Right? From the word, again you can understand, I will repeat it. Yes, the energy change, right? The change will occur when an electron is added to the gaseous atom. That is called as what? That electron gain energy. Actually, most of the atoms, the energy is released when electron is added, right? So when you take the example, the electron gain energy for chlorine atom is shown in the process is minus 349 kilojoules per mole. That means, guys, all this is releasing energy. So what is the state of this minus? Why we are calling this is as minus? Why this negative sign? The negative sign is implies what? The release of the energy, right? So this is what the most of the energy, most of the atom during the electron gain energy is releasing the energy, right? So look at this example, the chlorine. So what is your definition? The energy change that occurs when a chlorine gas atom, right? When an electron add to the chlorine gas atom, that is we are called that electron gain energy of chlorine. So you know the value, that is minus 349 kilojoule per mole. This is what is the reason why this negativity is what? The release of the energy. The most of the atom shows what? Releasing energy during the electron gain energy. So you can see what we are telling is the delta E dE during the electron gain energy, that is you can write as dE each electron gain energy. Right. Next. So we have an idea. We already said the most of them are possessed what? During an electron added to the gaseous atom, it possesses the release of the energy, but some of the atom shows the positive electron gain energy. Those are beryllium and nitrogen. Why is so? The beryllium is showing the full configuration and the nitrogen showing the half-fill configuration. Compared to others, it's showing the relatively stable configuration. Therefore, it's somewhat difficult to add the electron. Why? It's fulfilled with the electron. If you add the electron, there should be what? The electron-electron repulsion is dominating factor. That's why during this process, absorbing energy, therefore, the electron gain energy during this process becomes positive for beryllium and nitrogen. And you can see here the nitrogen gaining what the electron, becoming as a minus electron, right, minus gaseous atom. So this is what you can see the values. This is positive 134 kilojoule per mole, and the beryllium is the positive 231 kilojoule per mole. Why this reason? Yes. So simply you can understand the nitrogen is the half-filled one. Yes, it's 1s2, 2s2. Okay, nitrogen is 1s2, 2s2, 2p3, half-filled one. That's why that energy. The beryllium is what? 1s2, 2s2, fulfill one. So therefore what? It has a little bit more energy. That's why it's absorbing the energy during the electron gain process. Therefore, the electron gain energy for this the nitrogen and the beryllium is positively charged. Right. Next, we will go for the electron gain energy. I'm going to speak about the periodic table. The electron gain energy is become less positive across the period and more positive down the road. So this is what you should be able to understand. The left to right, the electron gaining energy is less positive. And the down the group is more positive. And this is we are talking about what? Electron gain. This is what we are calling the electron gain energy. Across the period is less positive, down the periods is more positive. So this is the periodic action of the electron gain energy as accepted internationally. The delta E electron gain energy, the energy of the electron gain energy is used as quantitative physical quantity to measure the attraction of electron by an atom and related to the electron affinity as follows. So when we want to introduce about the electron affinity, right? So the internationally they have described and they have published that the quantitative value, right? So there is a relationship between the electron gain energy and electron affinity is given below. Yes, the electron gain energy, the energy of the electron gain, the delta E is equals to the negative sign. You can see that is the as it is the value is same, but the sign is different. They have the opposite side. But though if you said this is 192, the electron gain energy just a 192 now. The electron affinity of the particular electron, that is, sorry, minus 192. If it is minus 192, that's not. This is the relationship between the electron gain energy and the electron affinity. So what they are telling here? Thus the electron affinity of an atom can be closely related to the electron gain energy, and this is defined as the change in electron when an anion of element loses an electron for the gaseous phase. So this is what we have already studied is the electron gain energy is, yes, what is happening? The gaseous atom, right, accepting an electron, gaining an electron, becoming as what? Negatively charged under gaseous state. So during this it's absorbing or removing energy. That is what the electron gain energy. But what the electron affinity is the opposite of that. Here what is happen is change the energy, the anion of element lose an electron. Right, the anion of the element. We will see it seems to be similar. We will take again. Here the nitrogen minus gas anion of the element losing the electron and becoming the gaseous atom. This is what we are telling is, yes, this is what we are telling is electron affinity. Okay. And this is electron gain energy. And this is why we are telling is, though it have the value, we'll say x. So this should be minus x. That is the difference. So if you say this is x kilojoule mole minus 1, and we know nitrogen now is positive, and this is what? This is minus x kilojoule mole minus 1. So this is the difference between the electron affinity and the electron gain energy. And you should understand what is the relationship between these, right? And let me move on to the example now. And then I is losing, accepting like losing electron and forming what? The gaseous state of the atom. That is called what? Electron gain energy. So which is as the equal magnitude and the opposite sign to electron gain energy become more positive across the period and the less positive down the group. Again I will remind you all, yes, think about your electron gain energy, right? Electron gain energy, right? Yes, down the group it is more positive, right? Down the group it is more positive, along the period that is less positive. And when you take electron affinity, the opposite of that, down the group less positive, less positive, and along the period it's And this is the major difference between what? The periodic trend of the electron gain energy and the electron affinity. When you take the electron gain energy, right, it's along the period is a less positive, down the period is the more positive, but the electron affinity, what the opposite same magnitude, but the opposite charge. So because of that, what is happening along the period, that is the more positive, down the period, that is the less positive, right? Next we go for what? The electronegativity. So what is mean by the electronegativity? It's clearly defined. The electronegativity is the ability of an atom in a molecule to attract the electron itself. That is the electronegativity. What is meant by that? The ability of an atom in a molecule to attract the electrons. That means they are having the more electrons. To attract the electron to itself, that is called electronegativity. So greater the atom's electronegativity, it's a greater its ability to attract the electrons. That's all. So what is mean by the electronegativity? The ability of an atom in a molecule to attract the electrons to itself. So greater an atom electronegativity, you can say the greater its ability to attract the electrons. So the American chemist Linus Pauling in 1901 to 1990, he developed the first and the most widely used the electronegativity scale, which is known as the Pauling scale, which is now we are using to measure the electronegativity of the atoms. So he said, generally, say, there is an increase the electronegativity from left to right, the period of the periodic table. So what he said is, along the period, the electronegativity is increasing. And also, he said, with some exception, right, down the group from the top to bottom, what is happening? The electronegativity is decreasing. Electronegativity is decreasing. So this is what, according to his the Pauling scale, he has described along the period the electronegativity is increasing and the down the group the electronegativity is decreasing. Generally, there is an increase in electronegativity from left to right across the period in the periodic table, and with some exemptions, especially in the transition metal, the electron negativity decreases with increasing atomic number in a group. So that's why the noble gases to have very small but non-zero electron negativity according to the Pauling scale. So here the trend how they describe regarding the Pauling scale, even though left to right your electron negativity is increasing, but what is happening, your noble gas is showing very small amount of the electron negativity, not zero according to the Pauling scale. So in molecule, the difference between the electron negativity of the two atoms is described about what? The determining the bonds. It could be either ionic or the covalent nature of the bond. So it describes about the nature of the bond according to the electron negativity of two atoms. So from that only you can determine whether it's an ionic bond or the covalent bond. So the Pauling electronegativity values and the trends of the periodic table is given here. So according to that, you can describe about that. Please keep your eye here. Okay. So here you can see the yellow in color. That is your Pauling scale is the 202 to 2.9. It is showing somewhat a bit above the range, these are the area showing somewhat increased electronegativity. But the red color 3 to 4, the Pauling scale, it shows the highest electronegativity always for fluorine. Second one is oxygen. The order you might know, guys. Okay, so what is the order? The first one is the fluorine, and second one is the oxygen. Third one is the nitrogen, and your chlorine also will come together. And according to that, next we are going for the carbon, boron, and there are the things, right? But you should be able to understand these values are, we are telling, most highest electronegativity atoms. So that is what they have shown in red in color. You can see this red in color shown the highest electronegativity atom. The yellow in color, the second set of what is 2 to 2.9, that shows the second set of the electronegativity atom. And go for what? Your blue color is a light color. They said the transition metal and other metalloids and the metal showing the less amount of the electronegativity. We are telling either it's a less electronegativity or the electropositive atom. And you know the metals, alkaline earth metals and the alkali metals are its least electronegativity. We simply say those are electropositive atoms. This is what we are telling, right? So that word, that phrases and these variation, the trends you should be able to understand, right? So always across the period, right? The electronegativity is increasing except your noble gas. We are not talking about the noble gas. And down the group, the electronegativity is decreasing according to the Pauling case. And in between, right, the transition metal, because of the transition metal, we could not able to say there is, with some extension, you can say down the group, the electronegativity is increasing, right? So with that, I will conclude this presentation, guys, and also the unit 1. We have gone through the several presentations and the different kind of the theories. This is very important and showing the major impact of the atomic structure. Once you understand the atomic structure, then only you can realize the next chapter, right? So we have introduced the chemistry with your atoms, how it shows the impact. Maybe it should be the imaginary level, but you should study the chemistry behind of that, right? Anyhow, guys, we will start with the new lesson, that is unit 2, bond structure. With that, we can study about what is the bond and how the bond is making the different concept that we are going to study. It should be really interest for you all. Inshallah, we can start the new presentation as soon as possible. Until that, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh.